Okay, so now we're going to do some conversions. So this is kind of a higher level of problem than just trying to figure out the units of one thing. So what we're doing is we're taking a conversion in molarity and we're turning it to one or two, in this case, other units. I specifically chose these two units and left out the molality. We'll do the molality last because all three of these have denominators that are in terms of solution. Like this is per liters of solution. This is over total total moles of the solution. So it's everything together. It's the moles of solute and the solvent, the solution. And the same for the mass. This is the mass of the solute and the solvent. It's what goes in the denominator. So it's the mass of the solution. Molality is solvent, and so it takes a few extra steps. So we're starting with this level, and then we're going to move into molality. So right now what we have is, and this was supposed to say KBr solution, by the way. This was a KBr solution, it had that density. I'm going to go ahead and remind you all, if you didn't remember from the last video, the molar mass of that is 119 grams per mole. That's of the KBr. And if you needed the molar mass of water, then water is 18.01 grams per mole, and that's your water. So the way I suggest working these, you'll notice that I have two things that have two units. I don't have like a single unit. And usually when you do these factor labels, you start with the thing that just has one unit. First thing I recommend is rewriting this sentence so that it says moles of KBr over over liters of solution. And it's not just any liters, it's actually 1 liter of solution. That's what that means. That's that ratio, 1 liter of solution. Now, if we're trying to get to mass percent, so mass percent, I'm just gonna remind you, that's grams, in this case of KBr, the solute, over grams of KBr plus grams of water. Mole fraction is moles of KBr, and then over moles of KBr plus grams, moles, I was looking above, moles of H2O. So we actually know the top number in this one already, which is really, really helpful. And in this one, you might already kind of be able to see it wouldn't be too hard to get to grams of this total because we have the density. So I'm just going to do the percent one first because I just happen to have listed it first. So the percent by mass of KBr. So I'm going to start with my two numbers hooked together because they're not unhooked, but this is what I'm trying to find. So I'm going to start with 0.297 moles of KBr. And I'm going to draw a line and leave a little space and have my liters of solution right here. And what I'm going to do, I heard this method when I was in grad school, and I think it's a very helpful way to do these problems, is I'm going to deal with them separately. I'm going to get this part into the unit in this what I need and get this part into the unit I need. But at the end, when I get everything in the right units, then I'm going to remember that, hey, these are still connected to each other, and I'm going to take my final top number and divide by my final bottom number. I just think it helps organize the information a little bit better to do it this way. So for percent mass, I need the mass of the KBr. So I'm just going to go on top and I'm going to say in 1 mole of KBr. And I'm going to go ahead and put my grams, my 119 grams per mole, of course, of KBr. Can't seem to write KBr. Notice that gets rid of this unit. And now my top unit is in the right unit. So I'm in grams, which is great. Now I need my bottom unit to be in, it needs to be the grams of the total amount. So it could either be grams of solution, or I could take each of these separately and add them together and get grams of solution. So I'm going to take this one, I'm going to use my density. So I have 625 grams in 1 liter. I'm going to cancel out my liters. And so it's going to be 625 liters of solution. So I've got the other unit that I need. Grams of solution. Grams of solution. So I've got the other unit I need. I've got my total grams of everything, and I've got just my grams of my KBr. Don't want to forget to multiply by 100%. And when I put this in my calculator, it'll be, I'll just do the top and the bottom, So 0.297 times 119. And then that bottom number, if I hadn't, I could have put parentheses in and gone ahead and done the math like this. 1 times 625. But I mean, if you've already solved it, it's okay too. And then times 100%, and that gives me 5.65%. You might be thinking, oh, that's slightly different from what you got when you okay, this is a different problem. I am using very similar numbers, but I did round this one right here when I was working this problem.